Hello, this is Dr. Kelsey, famous neuroethologist. Today I will present a most curious specimen, Homo sapiens, in its natural environment.
We begin with what seems the most passive behavior, sleep, also known as the poor man's feast. The organism looks inert, the organism feels inert, but she is far from inert. She is active in the hippocampus, which extracts the important parts of new memories. Synaptic representations of insignificant memories weaken, but the connections grow stronger between neurons storing important memories, which become long-term memories stored in the neocortex, where they remain protected from the destructive touch of time. Let us see what cycle of sleep our specimen is in. Sleep cycles from REM down to stages 1, 2, 3, and 4 of deep sleep end up again to REM. She is likely dreaming, perhaps simulating a motor sequence to escape predators. Like all good things in life, sleep must end. Our second specimen now engages in perhaps the next best thing in life, eating. Humans have specialized taste buds on the tongue, soft palate, pharynx, larynx, epiglottis, and first third of the esophagus. Each of the 5 tastes is represented with its own types of receptors in taste cells. Our specimen, for example, tastes the pretzel saltiness on his tongue. NaCl binds to the ion-gated cells, which open in response to NaCl to allow an influx of positive ions. This depolarization sends an action potential through gustatory sensory neurons to the solitary tract in the brainstem. Information also goes through the thalamus to the gustatory cortex, which mediates conscious taste perception, and to the hypothalamus, which mediates feeding behavior. Even sleep and eating don't compare to the excitement of exercise. As this specimen prepares to engage in a ritualized physical activity, several parts of her brain activate. First, premotor cortex neurons fire as she prepares to swing the bowling ball. The premotor cortex is connected to the primary motor cortex, which executes the command to swing the ball forward. These neurons activate 5 to 10 milliseconds before her movement starts. Her supplemental motor cortex is involved in her mental rehearsal of the movements, which allow her to practice to perfection. All of these areas are modulated by the basal ganglia, which form an important feedback loop for all descending motor commands. At last, the command executes. Alpha motor neurons, which project through the ventral root of the spinal cord, synapse onto the muscle fibers in her arm and release acetylcholine, causing the muscle to contract to complete the motion. Modern times have made humans into mindless automatons glued to digital screens, and our specimen is no exception. Her fixed attention to the screen tells us that her occipital lobe, the site of visual processing, is active. Her retina transduces visual information from the television screen into signals processed in the primary visual cortex. Points in the visual field of the retina send information through the lateral geniculate nucleus to corresponding areas in the visual cortex. Upon reaching the visual cortex, information specializes into motion processing of the dorsal stream and object recognition in the ventral stream. Alas, this organism strongly relies on its visual system in its day-to-day processing of its surrounding.
Homo sapiens have come a long way from their evolution of lowly planula. Like the primordial soup from which it spawned, the Homo sapiens are a reservoir of potential. We wish it the best of luck on its evolutionary trajectory.